Well, today we're going to be looking at the geometric sequence and trying to define it. Let's understand first of all what a geometric sequence is by putting out a sequence for you. So you can see here there's a sequence, and you might be able to spot what's happening each time. It goes up by multiplying by 2. A way to understand how to get there, if you can't just see it, is to take one term, so let's label this just to help you. So I'll take the third term, 20, and divide by the second term. And that will give us what we call a common ratio. You can divide anyone's, 40 over 20, 20 over 10, 10 over 5. It'll always be the same because it's common. So in here, R equals 2. And another thing you need to know is we always have a starting value. And we call that A. So A is our first value. Now, we know we go up in 2's, so it's to the power of 2. So here, let's just do to the power of 2. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and don't forget, 2 to the power of 0. Let's see what that looks like. 2 to the power of 1 is 1, and it's 2, 4, 8, 16. Like this. So we can see how that's doubling up. So, how does that help us? Well, let's get this nice colour. What do I do to get from 1 to 5? What do I do from 2 to get to 10? Hopefully you can see you multiply by 5. So I times each of these by 5, I'll get the numbers I want. So 5 times each of these and I get my sequence. So the 5 is the coefficient, and then we have the common ratio of 2. And the thing you need to think about is this number here. Our first term, our second term, our third term. If it was our nth term, I wonder what this number would be. So if it was n, then it will be 2 to the what? Hopefully you can see n minus 1. And that's the name of this sequence. The general formula for that is this, therefore. A R to n minus 1. And that's how you name a geometric sequence.